Welcome to Ask and Learn.
Let's calculate the mass of glucose in kilograms that would be needed to provide 1,500 calories per person per day of nourishment to the global population for 1 year. So let's summarize some of our information. The number of people on Earth is 7 billion, so 7 times 10 to the 9th people. And the consumption of glucose is given to us in the question as 1,500 calories per person per day. So the total calories for 7 billion people in 1 year, or 365 days, would be equal to 7 times 10 to the 9th people we're going to multiply this by 1,500 calories per person per day times 365 days. We can see here that people will cancel, days will cancel, and we will find that we have 3.8325 times 10 to the 15th calories that would be needed. We'll convert calories into joules. 3.8325 times 10 to the 15th calories. Our conversion here is 1 calorie is equivalent to 4.186 times 10 to the negative 3 kilojoules. So this is equal to 1.6043 times 10 to the 13th kilojoules. We know that from the reaction that 2,803 kilojoules of energy is released when 1 mole of glucose is metabolized or we can flip this around. 1 kilojoule of energy is released when 1/2803 mole of glucose is metabolized. So if we have 1.6043 times 10 to the 13 kilojoules, let's calculate moles. 1.603 times 10 to the 13th kilojoules times, we can use either one of these, 2,803 kilojoules in 1 mole of glucose, and this will yield 5.7235 times 10 to the 9th mole of glucose. So now let's convert this into mass of glucose. So 5.7235 times 10 to the 9th mole of glucose times 1 mole of glucose has a molar mass of 180.156 grams. and we find that the mass of glucose is equal to 1.0311 times 10 to the 12th grams of glucose. We're asked to report our value in kilograms. So 1.0311 times 10 to the 12th grams of glucose, 1,000 grams in 1 kilogram, and we'll round off to 3 sig figs times 10 to the 9th kilograms of glucose. So this would be the mass of glucose required for the global population in 1 year to provide 1,500 calories.